Let's bring you on stage. Hello, Confidence. How are you?
Hi. Hi, Dan. Hi, Corey. I'm
Oh
very
my
well, thank
God.
Confidence.
you.
You're representing.
I'm representing.
Oh my God.
How couldn't I? This is such a comfortable hoodie. Really nice.
It is, right? Like it's like
Yeah.
wearing a blanket or something. They're just
Exactly. Exactly.
so every one of you go become an ambassador. Get yourself a hoodie like Confidence has. So, geez, I don't even know how to introduce you, Confidence. It would just take the next 30 minutes to do it. Cybersecurity Woman of the World. Did they not do a universe version of it? If you don't know the API Kitchen, you got to know the API. Corey and I have both been
we
in
both had the honor of being on the API Kitchen, spicing it up with confidence.
it. Exactly. You got your Cyber Safe Foundation, which is really an incredible thing. The way you give back to the community is unmatched. I love your posts where you share, young, up and coming superstars of cybersecurity. Merkle Fence, I think that's your firm. So definitely love to learn more about that. But with that, Confidence, I don't want to take too much time away from your session here, so take it away, please.
Thank you so much, Dan and Corey. Thank you so much to everyone at APIsec for the opportunity to kick off this amazing conference. And if my slides are coming up very soon, you'll get to see that I'm speaking about APIs, but from the context of zero trust and how AI and ML can generally elevate zero trust. So I'm going to be putting out some disclaimers, but before that, I will definitely, say a bit about myself, very little bit. I'm a two-time founder, like Dan has said. I'm also the cybersecurity one of the world, but I've won multiple other awards aside that. I love to speak about APIs in a way that people can relate to. We can move on to the next slide. Okay, great. Okay, so I like to speak about APIs using cooking metaphors or food metaphors, generally speaking. I'm not going to be doing that today because I don't want you to get too hungry. It's very early in the morning for some people. So yeah, we're just going to talk about APIs, but I will break things down as much as possible. I'm also a global speaker and I'm very passionate about gender inclusion. I really like to bring, and I do a lot of work around bringing more women into cyber. I'm also an author of a book that's coming out next month. It's called API Security for White Hat Hackers. So I'm shamelessly plugging that at the beginning of my presentation and also at the end, and you get to see more. But then speaking about AI and ML, I mean, that's sort of like a buzzword these days. Everyone is talking about it. Like you can't go 5 cm without hearing about AI and ML, right? You can't go 5 meters, I mean to say, without hearing about AI and ML, So, but I wanted to just put in this first disclaimer that AI is a software system and it's not a magic wand. Like it's a software, which means a lot of the things that applies to what we've known around securing software before now does apply to it. Maybe the major thing that we should then note is that first and foremost, AI in IT security is not new, but that AI is sort of like a broad field of computer science that is really focused on creating systems that are capable of performing tasks that typically, really require human intelligence. And then, in a nutshell, ML is then a subset of AI. So this subset of AI focuses on, development of algorithms that are using statistical models to enable computers learn. And very key thing to note there is around the learning capabilities of ML. And aside learning, it learns, but also makes predictions. And when we get to really mature this, it's going to be able to make decisions without explicitly being programmed to perform task. You will just be able to have these systems help with all of that using a bunch of data. Again, another key deliverable that AI and ML is able to deliver. So in a nutshell, AI is sort of like that overarching field that's concerned with creating intelligent agents, like we see a lot of them now. Corey mentioned one of them, ML is also a specific approach within AI that uses data that we're generating from our interactions with the network and all of those sort of things to enable machines to learn and adapt. So in this presentation, I'm going to be merging and showing you how APIs basically can benefit from AI and ML, but more zoomed in into zero trust and how it enables that. Now, we can't talk about all of this without basically talking about APIs. And I love this simple analogy a lot, which is that APIs are the waitstaff of the internet. There are many ways I've described APIs. I've described APIs as the plumbing system. I've described APIs in the past as today as waitstaff of the internet. And very soon I'll also be describing APIs as the glue of the internet. All of that works. I just don't want to assume that you're looking at APIs, talk about APIs, and you may not necessarily understand what it is. So I have this image, and I'm sure a lot of you have gone to restaurants. You're not seeing the chef. You don't know what the color of the pot he's using to make. You don't know what cooking utensils this chef is using to make your very yummy lasagna, for example. But then you get to come to the restaurant, which is the front end. You make a request through the wait staff, nicely dressed, usually simply in apparel like the one we're seeing on the screen right now. And then they get our order and they go back end and they're able to get our order and serve it to us. So that is possibly in the simplest way how APIs can be described, right? And so APIs really do quite a lot of work for us to ensure that we're able to use the internet and maximize all of the tools, all of the services that we really like to consume every day. Now, also APIs help to bring together and allow many software systems to be able to collaborate and communicate with each other. And so you're able to consume services in other services because of APIs. But then APIs have quite a lot of problems. And how do we solve this problem? Some of the problems include that APIs currently are the second top entry points for cloud compromise. That means that 16.5% of the breaches that we see in the cloud were made possible because of an API issue, an API vulnerability. I'm going to be touching on some of those vulnerabilities very soon. We've also seen from recent surveys that nearly half of organizations identify managing API sprawl. That means, not knowing what APIs you have, where they are, what they're doing, as a top concern, followed by, of course, maintaining an accurate inventory of them. A lot of organizations cannot tell how many APIs they have and do not have them centrally managed. And that is a major issue because we cannot really protect what we do not know. We cannot protect what we do not know and understand. And so that is a key dynamic of the problems around APIs that are really posing major threats in our ecosystem. Now, another key thing to note is that there are a huge number of APIs required for, to power the basic application. So between 26 to 50 APIs are required to power the average application that we use every day. And then 1 in 3 organizations release API updates daily. Now, really just going back to what Dan had mentioned, with the fact that these APIs are going out so frequently daily, but then testing is not a thing that is prioritized as well. So API testing is not being able to meet up to the pace of release. Developers are releasing APIs every day, every week, but are they getting tested? Are they going through, proper governance structure that needs to be put in place? All of that is quite an issue. We also see that 900%, there's been a 900% increase in attackers looking for shadow APIs. And that's very explicable because if, for example, you do not know that that particular API exists, then it becomes an entry point that's very, very easy to then use because those APIs are communicating with systems, they're communicating with databases, they're communicating and passing on sensitive information and personally identifiable information. But that said, and with all of the explosion that is happening with APIs and the fact that they serve as a glue, right? A key thing that I want to also talk about is that because of the role that APIs are playing, they have become the new network. So they have become the new network, meaning that we look at APIs from the context of the application layer, but then they've become the new network because they're in modern applications that are being built, that are the conduit between all the components and all the users. And API becoming the next layer of the network, enabling communication and enabling data movement. So the application layer, again, wasn't something that was is the same way it was when zero trust was introduced. And that brings us to the conversation around zero trust. When zero trust was introduced in 2010 and became very popular between 2014 to 2015, we didn't have APIs in this state of explosion that we're experiencing it 10 years after. We do not have, for example, the use of microservices and applications being cloud natives like we're currently having, and the role of APIs being this strong. So those significant advancements in how applications are being built and how applications are being deployed and how modern applications are even composed, are key issues that then drive, how are we implementing zero trust for APIs on the application layer? And I'm going to speak a lot about this, but I just wanted to share that, because they're the glue serving this interconnected world, we need to be able to take good care of them, ensuring that they're protecting very sensitive information that's going through them. But I can't talk about all of the problems of APIs without highlighting the top 3 bad guys, right? The top biggest problems that if we were to talk about single biggest problems, we would definitely be highlighting them. And why is it important to talk about these 3 big issues, which is broken authorization and broken authentication, as well as excess data exposure? Is because we've seen that 90% of data breaches we've seen, 90% of them are, have these particular bad guys in the mix. So these vulnerabilities are present in 90% of the breaches as we speak. So if we are able to basically tackle to a great extent broken authorization, broken authentication, and access data exposure, we will most likely have been able to mitigate 90% of the threats to our APIs. And that's why these guys need all of the focus in the world that they should get. So I want to share a bit of a story. So we take this back home and we're able to see how all of this comes together. So I've been privileged to be part of many API security, implementations, API security tests, and all of the works. And I want to share one of those experiences that happened that really would help us understand how these guys being broken authorization and authentication and exposure of data actually get to happen. So we had this particular engagement that I was part of, and we identified that we identified certain endpoints that were permitted to, or rather that people could access information from without authentication and without authorization. So you had access to personal identifiable information that in the context of what we're looking at was going to be able to enable loan request data. So loan request data could have been collected without authentication and authorization. And this included sensitive information like addresses, phone numbers, and a whole lot more. So people could access that information data and that data by merely providing the loan IDs, which again, the loan IDs were 10 digits long. With a 10 digits long ID, you can easily brute force it. You can easily guess what those 10 digit IDs are, and you can easily get the information that you want to get. So what were we able to do? We used forcing capabilities, and we're able to guess some loan IDs, and we're able to extract some data, and we're able to show to this particular clients we're working in, that this was a significant vulnerability, and that people were able to access this information through endpoints that did not have authorization and authentication. Now, a lot of times when you hear authorization and you hear authentication as a vulnerability, we usually think maybe authentication, isn't properly implemented. But in the case that I've just spoken to you about, it's not that it wasn't properly implemented in those particular endpoints. It was the fact that it wasn't even available whatsoever. So the endpoint existed and was passing out sensitive information without authentication or authorization. Now, this is very, very horrible for it to happen, because it just means that we don't have keys to our doors, and our doors are flung wide open. In fact, anyone can walk in through our doors. Anyone can do anything within our APIs. And so this is not exactly also a unicorn case. I've seen so many cases where there are APIs that are transmitting sensitive information without any authentication or authorization in place. But then how does this convert? How does this relate to zero trust network? And to really take it back to how it relates to zero trust network, I really want to talk about how we currently have it, aside AI and ML and before zero trust, in terms of protecting the enterprise. So the traditional model of protecting the enterprise is that once you're in, we assume that once the connection, once the network, once the communication is coming from within the organization, then we assume that that guy is safe. Like that person talking to you is someone that should talk to you and should touch the resources they're touching. But that presumption is very, very wrong. And I'm going to be touching on why this is the case as we go forward. Now, another key thing to also note is that we've had zero trust really implemented for a long time, for years now. I mean, Google made it very popular in 2015 and all of that. So we've had zero trust for a while, right? But then zero trust has typically focused on the network layer and has left the application layer in most cases, and in most enterprises I've had the privilege of looking through, is that zero trust, as we see today, is most times focused on the part that is the network. It doesn't have much to do with the APIs. But then when you don't have the APIs covered in your zero trust efforts, then what exactly are you doing? You cannot have that as a good way to do things when significant advancements have been made in how applications are built, and a lot of modern applications use microservices and are cloud native. So if there is no zero trust implementation for APIs that our applications heavily rely on, then we're introducing new kinds of issues to environments, and of course allowing for the kind of things that I spoke about earlier on to actually happen. And that is not something that we definitely want to happen. So without API security, you cannot achieve zero trust security, not at all. So you cannot achieve zero trust security, and that's why it's very important to implement this. But how does it differ in the real sense of it? I wanted to put a side-by-side, comparison here, so you can basically see. First, I said traditional security says when you're within the perimeter, you're within the organization. In the context of APIs, you're consuming locally, an internal API, for example, one that you're not exposing to the outside world. You're basically supposed to trust everything that happens on that API, right? Because it's just within the enterprise. It's just within the staff that use that particular tool. So it's not one that is exposed to everyone else. So you're relying on the fact that because it's within the internal parameter, then it's secure. But then for zero trust, we're saying whether or not it's internal within the internal network, whether you're exposing it to your partners as an API or not, whether it's a service that is consumed by people over the internet, just about anyone using it, no trust should be implicit. Like, you should always verify, right? Traditional security also says trust internal network users and their devices. But then for zero trust, you're saying, no, do not do that. Do not do that, guys. Why is it important to continuously verify every request? Because someone could pose as maybe an employee of an organization, get access, and land into the enterprise. And once they're in, they have access to everywhere. I want you to close your eyes, for example, and imagine that you'd had no doors and no keys to your doors in your house, and it was a really big mansion. That means once I come through the front door, I could go anywhere. I could go to the master bedroom and take a dump, for example, right? I could do just about anything. I could go and use the exotic things in the house because there is no lock and keys to the different boxes within that house. And so, or different rooms within that house. And that's exactly what we're seeing here. For zero trust, you can get access in, but you need to produce a key, and you need to prove that you're who you say you are, and you have the access to do what you have the authorization to do what you want to do at every point where a request is being made. And that's what zero trust is in this context. Another key thing to mention is that we cannot deal with making sure that rules are kept, with how much data and how much interactions are happening. Now, again, going back to the way applications are now built. Applications are not built as one whole monolithic service or an application as a whole. They're broken into tiny segments. And so if we are trying to collect all of that data, say what should be done, process it and check who is who per time, rules will not cut it anymore. We need a bit more automation. We need to be able to learn from all of what we are seeing as activity, to be able to tell and discern what is okay to do on a network and what is normal to happen on a network, as against what could be malicious activity that could hurt us. I'm really running out of time, so I'll run really fast with things going forward. So now moving on from there, I also want to really put on another disclaimer, because a lot of times when we talk about zero trust, people sort of like zoom in into, okay, so what product is this, or what product can I implement in my environment to basically make my APIs or the whole of my network stack basically to be to have zero trust, right? To implement zero trust across my enterprise. I want to say here, first and foremost, that zero trust is not a product. Zero trust is a shift from what we know as traditional security to what I described earlier on, where you're basically not implicitly trusting anything. People and devices and everything else, have to be really verified per time to be able to know that, everything is going on okay as designed and there is no malicious activity going on. And when malicious activity gets to happen, it's easy to also detect. And I like to use an analogy, of going into a nice lounge that maybe is restricted for just certain customers with zero trust. What that means is that each time you go in and out of that particular that particular lounge or that particular club, for example, you will be inspected to see that you do not switch clothing with someone else and someone else is coming into the lounge that shouldn't have access to it. So definitely it's about really verifying everything. And so I put together these 3 pillars, just making sure that I'm able to meet within the time. I'm going to run through them very fast. The first pillar is that nothing should be trusted, and of course, aside nothing being trusted, is just the mere fact that you should give the least privilege to things. So just about enough access to do what needs to be done for each user is something that zero trust really holds dear. Micro-segmentation as well is a key thing that is really, really emphasized with zero trust. And why is that important? I mentioned the example of a very huge house, right? And then if you just allow for just one door coming through that one door to give access to just about every room, then it means that when an attacker comes in, you can't look at an attacker within the house. Now, with micro-segmentation, it means that an attacker could actually get into one of our boxes, but not be able to have access to the entire enterprise to just wreak havoc across board, travel across, the enterprise and do just whatever they want to do. Another key pillar is continuous verification, like I mentioned with the example of the nightclub or the lounge, where you're continuously seeing, okay, is this who you are? And what are you allowed to do? You're continuously verifying that. And so, but how do we then apply zero trust APIs? When I spoke about how authentication and authorization is really lacking, when you're not able to verify, you don't have any sort of measures in place or controls in place to verify that people have access to certain resources and they are authorized to use those resources, then that's a challenge. Also, the implementation of fine-grained access control. Who can do what? At what time can they do those things? That's another level of fine-grained access control, and that's what zero trust can definitely enable. There's also the angle of encryption and data integrity, and there is an angle also of continuously monitoring and logging what's happening on the network, and that's where zero trust really comes in. But then, what are the use cases? How do you get to use AI and ML to ensure that APIs are secure and they are the best of levels that we can get them to? Again, machine learning has existed in security products and all those kind of things, and IT security, generally speaking, for years, right? This is not the first time, but it's beginning to grow. It's becoming more popular these days, and a lot of new software, softwares are also including it. But it already exists in a lot of application security tools right now. So, what are the use cases? First, anomaly detection. Now, it's very difficult with certain attacks that I've gotten to see in recent times where to detect usual activity from unusual activity by just using your human abilities, right? Sometimes it lies in just looking deeply within the patterns of the data and the traffic to be able to tell. And that's something that AI and ML does very well. They're able to learn from data. They're able to do better than rule-based systems. They're able to grow with the dynamic changes of the threat landscape, and able to learn and know what is normal and what is abnormal. There's also threat hunting, where these tools are able to proactively identify malicious activity, right? Again, they've learned what normal is by just studying what happens within your environment, so they're able to tell what abnormal also is, right? They're also able to do automated incident response, and again, behavioral analysis is something that they're able to do very well because of the amount of data being collected and processed per time, which is typically not something that we can do, or without using AI and ML. So again, the visibility is something that's very key. If you're not able to see what APIs you have, you're not able to inspect them, you're not able to protect them fully. And so you cannot also fully police least privilege. You're not able to always verify, if you don't have these pillars in place. Just really running off to possibly the end of my presentation, I wanted to mention also that this is where all of them marry, like where I marry all of them, which is zero trust, AI and ML, and just robust protection for APIs. You have, first of all, that you'll be able to have AI-powered dynamic access policies. Like I mentioned earlier on, there's a lot of changes in the threat landscape. Again, with AI's introduction and being leveraged by threat actors and by the bad guys, being able to also change our defenses and equip our defenses to be agile enough to protect our APIs is something that AI-powered tools can do very well, of course, with zero trust being implemented. There's also the need to protect AI models against attacks, because like we see, they're also being attacked. And also the visibility for adaptive and proactive security changes is something that really needs to be done. But then, aside all of this, as I wrap up my presentation, we cannot do all of this without ignoring the challenges and considerations. The first key thing is we are not going to be replaced by AI anytime soon, as it has to do with AI API security. And I just wanted to mention that. There's also the need to mitigate bias in AI and ML models. Also, how do we ensure that we're able to reduce the false positives is another key thing that we need to grow in the use of AI and ML as well. There's also need to easily understand why did the AI make the decision, why did the ML make the decision around this particular traffic that came in through our APIs. And also data privacy and compliance is a key thing. But as I really wrap this up, as I've spilled over my time by 2 to 3 minutes, I want to say that, we should definitely leverage technology to enhance security postures for our APIs. But this won't be just use of software. It won't just be a piece of software, but it will be a thought through overarching strategy that you will need to use. And then I want to also encourage you to order my book, pre-order my book, which is coming out next month. It's going to be delivered to you next month. So, but pre-order it so you're getting the price before it gets to be released. I discuss quite a lot around API security and how you can maximize controls and all of the new technologies around protecting it as well, from the defense and of course the offense strategies as well. Thank you so much, APIsec, for the opportunity to discuss these issues and to just highlight how AI and ML can really help with zero trust in API security. Thank you, Corey. Thank you, Dan.
Hey, Confidence, great talk. Can't wait to pick up a copy of your book.
Thank you so much, Corey.
Yeah, I feel like a little inadequate. I haven't written a book yet. So, we have like a bunch of authors on the session. We did get I know we just have a minute or two. Let's just pop a couple questions. Where are these stats from Esteban? This was earlier in your talk. Do you know what he's referring to?
Okay, so I'm going to put some of the links to the sources for the stats somewhere in my presentation, and I'm going to share that with your team,
Oh,
so you get to
wonderful.
see that. Yeah.
I know there were some people asking if they could get a copy of your slides here. And gosh, we are really out of time, but let me just throw this one from Wolfram. I'm curious what your thought is on this comment.
I mean, the truth is, you can't have zero trust is very, very, it has to be like rounded, and it has to be ingrained in just about every part of the enterprise. So it's something that it's not something that you need to layer on. It's something that needs to be at every part, every stack, of our technology, ensuring that we have it across the enterprise, and not just in one area. Because when we are protecting just one part of the house, like I mentioned, we are haven't yet protected the whole house, and that's a key thing that I just wanted to highlight in this presentation.
There's a bunch more questions here, Confidence. Unfortunately, we just ran out of time here, and so we're just going to have to invite you back and have more conversations with you. But thank you so much, Confidence, for joining us here today and for being the kickoff for APIsecCon #1. We love you. You're great, and please keep doing what you're doing.
Thank you so much, Dan. I really appreciate your kind words. Bye, Corey. Bye, Dan.
Bye.
See you, Confidence.
Bye, everyone.